We are going to start now lecture 3 of chapter 7, class 11th mathematics, permutations and combinations. We start this chapter with the definition of permutations. So suppose we are saying that some different things are being given to us. So these are three different things given to us, and we want to make different arrangements with these three things. I am talking about, suppose first I have chosen this minus sign. I am choosing all these three things. Next I am choosing this cross sign, and then I have chosen this dot sign. Similarly, suppose I have chosen first this cross sign, then this minus sign, and then this dot sign. I would have chosen this dot sign, this cross sign, or this minus sign. So this kind of arrangements we are talking about. This kind of arrangements we are saying, that is the different arrangements which can be made out of a given number of things by taking some or all at a time are called permutations. So the important thing to note over here is that order of the arrangement of the object is taken into consideration. We are saying that if we are choosing this first, then this cross at second place and dot at second place, this is different than choosing cross at first place, this dash at second place and dot at third place. Similarly, suppose we have three letters A, B, C, and we want all permutations by taking two letters at a time. So we will have A, B, we can have B, C, we can have C, A. So these are A, B, B, C and C, A. Now corresponding to this A, B, we will have another B, A. We would have chosen another combination, that is B and A. Corresponding to this B, C, we would have chosen C and B, and corresponding to C, A, we can choose A, C. So the total number of permutations we can have, it is 6. Next we are seeing all permutations of the letter A, B, C. Again same letters we are talking about, A, B, C. Now the difference is we are taking all of them at a time. Over here we are saying 2 were taken at a time. Now we are saying all of them are taken at a time. So we are saying we can make the permutation, that is A, B, C, that is A is chosen first, B is chosen at second place and C is chosen at third place. Another combination we have is A, C, B. A is chosen at first, C is chosen at second and B is chosen at third place. Then we have B, A, C, then we have B, C, A. Similarly, we have C, A, B and C, B, A. So these are all possible permutations, all 6 possible permutations that can be formed by using these letters A, B, C when all of them are chosen at a time. Next we have is all permutations of the letter A, B, C, D, we are saying taking 3 at a time. We have to take 3 letters. So we are saying the permutations, the possible permutations is, we are talking about A, B, C. Suppose I am taking these 3. First of all, what I have to do, I have to choose 3 letters from this. I would have chosen A, B, C. I would have chosen A, B, D. I would have chosen B, C, D. I am talking about 3 letters. And last I am talking about it is A, C and D. Corresponding to these 3 letters, we would have A, B, C. We can make A, C, B. We can make B, A, C. We can make B, C, A. We can make C, A, B, or we would have made C, B, A. Corresponding to these 3 letters A, B, C that we have chosen, we will have 6 objects over here. Similarly, corresponding to this second, if we are choosing A, B and D, we can make 6 different permutations. Corresponding to these 3, we can make 6 different permutations. Corresponding to these 3, we can make 6 different permutations. So the total number of permutations we have, it is 24. So we are saying the 4 letters A, B, C, D taking 3 at a time give 24 permutations. Next we have the formula for permutations when all the objects are distinct. So suppose we are saying that we have n different objects and we are choosing r at a time. We are choosing r different objects from n different objects at a time. What we mean to say is, suppose we have different objects. Suppose this is the first object that we have. Next we have, this is the second object that we have. This is the third object that we have. This is the fourth object that we have. And likewise we have n different objects. We are saying these are, this is first, second, third, fourth, and this is nth object. Now out of these n objects we want to choose r objects that should be distinct. So we want to calculate the number of ways in which we can choose these r objects. So we are saying, if we want to choose the first object, how many options we have? We are saying we have total n options. I am talking about the first object when we choose. How many options we have? It is n options. When we choose the second object, the number of options we are left with. Suppose we have chosen this one. In the first place, we have chosen this object. Now the number of options we are left with is n minus 1. Now the number of options we are left with is n minus 1 options, because one object is already being chosen and we want the objects to be distinct. Next, suppose we are choosing the object, say this 2 we have chosen at this second place. Now the third object we are choosing, how many objects we are left with from which we can choose? It is n minus 2 objects. Suppose we have chosen this 3. Suppose we have chosen this 3 at this third place. Now likewise if we continue, we are saying when we choose the rth object, how many ways are there? There are total, when we are saying we are choosing the first object, the answer we have is n minus 0. It is, we are writing it is n minus 1 plus 1. When we are choosing this second object, we are saying it is n minus 2 plus 1. When we are choosing this third object, so it is n minus 3 plus 1. So if we are choosing the rth object, the answer we have it is n minus r plus 1. These are the number of ways in which we will be able to choose the rth object. That is, at this point, these many elements will be left over here. So the total number of ways by multiplication theorem we will have, it is n into n minus 1 into n minus 2, so on up to n minus r plus 1. And this term we are saying, this is represented as NPR. Means out of n objects we are talking about the r permutations. This is the notation we have. We can write it is PNR, or we can write it as NPR. So this is the notation where this n means, this first n we are saying, this is the total number of different objects that we have. This n is the total number of different objects we have, and r means that r objects are chosen at a time. So this is the notation we have, and the formula we obtain it is in this form, that it is n into n minus 1 into n minus 2, so on up to n minus r plus 1. So if we talk about this term, we are talking about this term over here, that NPR is equal to this. Now if we multiply and divide this term with, say I am talking about the next term is n minus r, then it is n minus r minus 1, so on up to 3 into 2 into 1, and divide it with n minus r minus 1, so on up to 3 into 2 into 1. This will not change the answer. Now look at this term, it is 1 into 2 into 3, so on up to n minus 2, n minus 1 and n. So this whole numerator part we are saying, this is just n factorial. And if we look at this denominator part, we are saying it is 1 into 2 into 3, so on up to n minus r. So this denominator part we are saying, this is n minus r factorial. It means the final formula we obtain over here, it is npr, that is equal to n factorial over n minus r factorial. This is the final formula, or not the final formula, we are saying this is just another form of formula that we have mentioned over here, that npr is n into n minus 1, n minus 2, so on up to n minus r plus 1. So this is how we can write it in the factorial form, where if the condition we have it is 0 is less than r is less than equal to n, because out of these n objects we are choosing these r objects, so this r is always less than equal to n. Next we have is to calculate the number of all permutation of n objects taken all at a time. So we are talking about the case that npn. We are talking about the case npn. So we are saying that suppose we have n objects, we have n different objects, it is first object, second object, third object, so on up to we have n objects, and now we have to choose n objects out of this. So at the first place, when we are choosing the first object, we have number of options we have, it is n. When we are choosing the second object, the number of options we have, it is n minus 1. Continuing in this way, when we are choosing the nth object, all n minus 1 are being chosen, we are left with is one option. By using the principle of multiplication, counting principle of multiplication, we are saying that the total number of ways we have, it is npn, that is equal to n into n minus 1, so on up to 3 into 2 into 1, and that is equal to n factorial. So we are saying that the number of ways of choosing n different objects all taken at a time, it is n factorial, and the value of npn we have, it is n factorial. Now we use this npn is equal to n factorial to prove the fact that 0 factorial is equal to 1. So we are saying the formula we have, npr is equal to n factorial over n minus r factorial. Now if we are using this formula to calculate the value of npn, the answer we have, it is n factorial over n minus n factorial, that is equal to n factorial over 0 factorial. And from this term we are saying, the answer for this is equal to n factorial. So this implies us that 0 factorial is equal to n factorial over n factorial, that is equal to 1, and this is what we already know, that 0 factorial is equal to 1. Next we have certain problems based upon these formulas. So first is we have to calculate the value of 12p4. So it is 12 factorial over 12 minus 4 factorial, that is equal to 12 factorial over 8 factorial. This is equal to 12 into 11 into 10 into 9. And when we multiply these values, the answer we obtain, it is 11880. Next is 75p2. So that is equal to 75 into 74. Why? Because the formula we have, it is 75 factorial over 75 minus 2 factorial. The value of this term, it is 73 factorial. Now we can write 75 factorial is equal to 75 into 74 into 73 factorial. If we divide both sides with 73 factorial, the answer we have, it is 75 into 74 is equal to 5550. So this is our final answer. Next is 8p8. This is the value. We know it is equal to 8 factorial divided by 8 minus 8 factorial, 0 factorial, so it is 8 factorial, and the value of 8 factorial, if we calculate, that is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. When we calculate this value, the answer we will have it is 40320. This is the answer that we will have. Next is find the value of n such that np5 that is equal to 42 into np3. So if we apply the formula over here, this means n into n minus 1 into n minus 2 into n minus 3 into n minus 4. This is the value of np5. Why? It is n factorial over 5 factorial. So this is equal to n minus 5 factorial. Yes, not 5 factorial, it is n minus 5 factorial. So it is n minus 1, n minus 2, n minus 3, n minus 4 into n minus 5 factorial, and we divided with n minus 5 factorial. These two terms get cancelled and we are left with this term. It is n minus 1, n minus 2, n minus 3, n minus 4. This is the value of the term np5, and it is being given that this is equal to, this value is equal to 42 into n minus 1 into n minus 2. This is the value of np3. N gets cancelled, n minus 1 gets cancelled, n minus 2 gets cancelled. We are left with is n minus 3 into n minus 4 is equal to 42. This implies us n square minus 7 n minus 30 is equal to 0. This implies us n is equal to 10 or minus 3. The value of n, we are saying it is always positive, so minus 3 is not possible. So the value of n we obtain, it is equal to 10. Similarly, in this next question we have np4. So np4 means n into n minus 1 into n minus 2 into n minus 3 divided by, in the denominator we have it is n minus 1 p4. So it is n minus 1, n minus 2, n minus 3 and n minus 4. We are saying the term we have, if it is, we are talking about this term, it is n minus 1 p4. So that is basically equal to n minus 1 factorial over n minus 1 minus 4 factorial. N minus 1 factorial means n minus 1 into n minus 2. This value we have, it is n minus 5. It will continue up to n minus 4 into n minus 5 factorial. These two terms gets cancelled and we are left with the term, we are left with this term. It is n minus 1, n minus 2, n minus 3, n minus 4, and this value is given to be equal to 5 by 3, and the condition on n we have, it is greater than 4. So from these terms we are saying n minus 1, n minus 2 and n minus 3 gets cancelled. We are left with this n minus 4 by n is equal to 3 by 5. This implies us 1 minus 4 by n is equal to 3 by 5. This implies us that 1 minus 3 by 5 is equal to 4 by n. This implies us 2 by 5 is equal to 4 by n. And the value of n we obtain from this, this implies us n is equal to 10. This is the value of n that we obtain over here. We are saying n is equal to 10. Now next question we have is, if np4 is equal to 2 times 5p3, so it is n into n minus 1 into n minus 2 into n minus 3, that is equal to 2 into 5 into 4 into 3. The value of n 5p3 that will be equal to 5 factorial over 5 minus 3 factorial. So it is 5 factorial over 2 factorial. So it is 5 into 4 into 3 into 2 factorial divided by 2 factorial. So we have 5 into 4 into 3. So this equation we obtain, it is in the form n into n minus 3 into n minus 1 into n minus 2, that is equal to 120. This implies us n square minus 3n into n square minus 3n plus 2 is equal to 120. Now if we substitute n square minus 3n is equal to m, if we substitute this value, then this equation will become m into m plus 2 is equal to 12. So this becomes m square plus 2m minus 120, that is equal to this term we are saying it is not 12, it is 120. So we are saying it is equal to 0. So on solving this we will obtain it is m square plus 12m minus 10m minus 120 is equal to 0, and this implies us that the value of m can be minus 12 or 10. We are talking about values of m, we have it is minus 12 and 10. Now the equations we have obtained from this, we are obtaining two equations. One is n square minus 3n is equal to minus 12 and n square minus 3n is equal to 10. So when we solve these equations, when we are solving this equation, we obtain the values for n as is minus b plus minus square root of b square minus 4ac upon 2a. These values, these are imaginary. We are not interested in the imaginary values of n. We are not interested in these values. From this equation we are getting it is n square minus 3n plus 10 is equal to 0. That is n square minus 5n plus 2n plus 10 is equal to 0. And this gives us two values of n. We are getting it is n minus 5 into n plus 2 is equal to 0. So on solving this, the final answer we obtain it is n is equal to these values. Out of these values, this imaginary part is not possible, this negative part is not possible. What we are left with is n is equal to 5. So this is our answer over here, that is the value of n we have it is 5. Next is if 15 PR is equal to 2730, we have to calculate the value of R. So we are saying it is 15 over here and the value of 15 PR we have, it is 15 minus 1, then 15 minus 2, so on up to 15 minus R plus 1. So if we try to this number in these terms, we are talking about the factors of 15, 14, 13. So if we divide this number 2730, if we try to factorize this number, we will obtain that the answer we have it is 15 into 182. Divided with 15, we get it is 15 into 182. That is equal to 15 into 182. We are talking about, we are writing in terms of 14. So it is 14 into 13. So how many terms we have? We have 3 factors or terms we are saying. We have 3 terms or we are saying there are 3 factors. So the value of R we have that is equal to 3. The value of R we have it is 3. Next is 10 PR is equal to 5040. So it is 10 PR, we can write it is 10 into 504. This is equal to 10 into 9 into 56. This is equal to 10 into 9 into 8 into 7. Number of factors we have over here. We are saying number of factors we have, it is equal to 4. and that gives us the value of r, that is r is equal to 4. Next is if 56 PR plus 6 is to 54 PR plus 3. So we are writing it is 56 factorial divided by 56 minus R plus 6 factorial. This is into, we are saying this is into, we have 54 factorial, 54 minus R plus 3 factorial, and the value is given to be 30800 is to 1. Look at these two terms, we are left with this 56 into 55, and when we look at these two terms, we are saying it is 56 into 55. This value we are saying on solving, simplifying this value, we will get it is equal to 51 minus R, and this value we have it is 50 minus R. So answers we are getting it is 51 minus R factorial divided by 50 minus R factorial, and this value is equal to 30800. Now look at this term, we can write it is 51 minus R into 51 minus R minus 1 factorial. This term we are saying this is 50 minus R factorial. So these two gets cancelled. So what we are getting is that 51 minus R is equal to 30800. So the value of R that we obtain, it is multiplication, we have 56 into 55. We are talking about these two terms, it is 56 into 55 is already there. So when we divide these values over here, when we divide this 56 into 55 over here, we obtain it is 51 minus R is equal to 10. So this implies us that the value of R that we have, that is equal to 41. This is the value of R that we have. Next is 2n plus 1 Pn minus 1. It is 2n plus 1 factorial divided by 2n plus 1 minus n plus 1 factorial into 2n minus 1 factorial, and in division we will have over here it is 2n minus 1 minus n factorial, and the value is given to be 3 by 5. We can write this term as 2n plus 1 into 2n into 2n minus 1 factorial divided by, on solving this term we get it is n plus 2. On solving this term we are getting it is n minus 1. So we can write it is n plus 2 into n plus 1 into n minus 1 factorial multiplied by this term we have, this numerator we have it is n minus 1 factorial divided by 2n minus 1 factorial, and the answer we have it is 3 by 5. So we are saying this n minus 1 factorial, 2n minus 1 factorial gets cancelled. This n and this n gets cancelled. So what we are left over here is that 10n plus 5, that is equal to 3 into n plus 2 into n plus 1, and it is 2 over here. This 2 is already there. So if we solve this equation, when we solve this equation, we simplify this equation, this will give us the quadratic equation. We are saying it is 20n plus 10 is equal to 3 times, it is n square plus 3n plus 2. So this gives us the equation 3n square minus 11n minus 4 is equal to 0. And on solving this quadratic equation, we are talking about this quadratic equation, 3n square minus 11n minus 4 is equal to 0. When we factorize this equation, the factors we obtain it is n minus 4 into 3n plus 1 is equal to 0. So the values of n we have, it is 4 and minus 1 by 3. Clearly minus 1 by 3 is not possible value of n. N is a, we are saying 4. In this case, the value of n we obtained is equal to 4. Next is 22pr plus 1. So when we write this term, it is 22 factorial over 21 minus r factorial into, it is 20 factorial, then it is 18 plus, it is 18 minus r factorial, and this value is given to be 11 by 52. So these two terms gets cancelled. We are left with this 22 into 21. Then these two terms gets cancelled. We are left with this 21 minus r into 20 minus r into 19 minus r. If we cross multiply these terms, we obtain, it is 22 into 21 into 52, that is equal to, if we look at these terms over here, we are writing it is 19 minus r into 20 minus r into 21 minus r, and it is 11 over, this 11 is there. Now to calculate the value of r, first of all we are cancelling this 11 over here, we are left with this 2. We factorize these terms and we try to write them in this form. We know that the value of r, it is a natural number in this case we are saying, or the whole number you can say, in place of natural number we can say whole number, and the maximum value that r can have, it is equal to, we are saying the maximum value of r that can have, it is less than equal to 18, because we have the term 20pr plus 2, and if r we substitute 18, these two values will, this value will become equal to 20. If we substitute any value greater than 18, the value of r greater than 18, it will not satisfy this condition. Then it is not possible to calculate 20p21 because we cannot choose 21 objects out of 20 objects. So we try to factorize these terms. If we factorize these terms, we get it is 2 into, this term we can write it is 3 into 7, and 52 we can write this is 4 into 13. So what this thing implies, if we collect some terms over here, we are saying this 3 and 4 we collect, you get it is 12 into 7 and 2 we collect, we get it is 14, and last we are getting it is 30, and we are saying this is 19 minus r, 20 minus r, and 21 minus r. So if we substitute the value of r is equal to 7, the answers we are getting, it is 19 minus 7, that is equal to 12, 20 minus 7 is equal to 13, and this 21 minus 7 is equal to 14. We will obtain the answer in this form. So we are saying that the value of r is 7 in this case. Next is we have to prove that npn, that is equal to npn minus 1. So if we are talking about the value of npn minus 1, it is n factorial over n minus 1 factorial. This is equal to n factorial over n minus n plus 1 factorial. This is equal to n factorial, and n factorial is the value for npn. So this is the first part we have proved, that npn is equal to npn minus 1. Next is npr is equal to, we are saying npr, that is equal to n into n minus 1 pr minus 1. So if we start with this term, the value of this term, it is n factorial over n minus r factorial. this is equal to n into n minus 1 factorial. We want the answer in terms of n minus 1. We want this n over here divided by the answer we require, it should be r minus 1. So we are saying that this term we are saying n minus r, we can write it as n minus 1 minus r minus 1 factorial. These two values, look at these two values, it is n minus 1 minus r minus 1, it is n minus r. Both these values, these are equal. Look at this term. This term is n into n minus 1 p r minus 1. And this is the second result that we are proving over here. Next is n minus 1 p r plus r into n minus 1 p r minus 1, that is equal to n p r. So if we calculate the values over here, we get it is n minus 1 factorial over n minus 1 minus r factorial plus r into n minus 1 factorial divided by, when we solve this value, it will become n minus 1 minus r plus 1, that is equal to n minus r factorial. We are talking about the left hand side. We are talking about left hand side over here. We will have this term. Now this term we can write it is n minus r into n minus r minus 1 factorial. So if we write n minus 1 factorial over n minus r minus 1 factorial common, from this first term we are left with is 1, and from this second term we are left with is plus r over n minus r. Now what is the value of r over n minus r? It is n minus r plus r. These two gets cancelled. So we are getting it is n into n minus 1 factorial divided by n minus r into n minus r minus 1 factorial. This value, this is not bracket over here, there is no bracket over here, it is n minus r minus 1. This is equal to n factorial over n minus r factorial. This value we are saying this is n factorial over n minus r factorial. And look at this term over here, I think it is n factorial over n minus r factorial, and this is basically the definition of NPR, and this is what we have to prove over. So you should remember these three results because these can be used to simplify the values of NPR. Next is, if R is less than S is less than equal to N, then we have to prove that NPS is divisible by NPR. It is being given that R is less than N is less than S is less than equal to N. So if we talk about the value of NPS, that is equal to N into N minus 1, so on up to N minus R plus 1, N minus R, so on up to N minus S plus 1, because it is given that S is greater than R. So we are saying that there must be a number R before S. So we are writing the terms in this form. Now look at this portion over here. We are saying look at this portion over here. This is the value of this much portion we are talking about. This is the value for this term we are saying. It is NPR into, these terms are left over here, it is N minus R, N minus R minus 1, so on up to N minus S plus 1. So these terms, these clearly show that this NPR, this is a factor of NPS. So we are getting over here that NPR clearly divides clearly divisible by, or we are saying it clearly divides NPS because it is a factor over here. Next is find the number of permutation of 7 objects taken 3 at a time. So the value we will have it is 7p3, that is equal to 7 into 6 into 5, that is equal to 210. Next is in how many ways can 6 persons stand in a queue? So we are saying when all the 6 persons have to stand in a queue, it means that we have total persons, it is 6. The number of persons chosen for each point we are saying, or each position we are saying, it is for the first position we are saying that there is a queue over here. We have 6 persons. So for this first position, we are talking about this first position, how many persons we can choose out of? We have 6 persons. Next, for this second position, one person is already chosen. We are left with this 5 persons. Then 4, 3, 2 and 1 person on the sixth position. So we are saying the answer we obtained is 6 into 5 into 4 into 3 into 2 into 1, that is equal to 720. Next is how many different signals can be made by 4 flags from 6 flags of different colors. So we are saying that we have 6 flags of different color. These are 6 flags of different color. Out of these 6, we have to choose any 4. We have to choose any 4 flags. So we are saying the number of flags we can choose is 6p4, because we are seeing how many different signals can be made. So if suppose these all flags, these are different, we are seeing the first flag we have chosen, suppose it is this flag. I think this is the first flag we have chosen. The second flag we are talking about, this is the second flag we are saying. Next, suppose this is the third flag we are saying. This is the third flag we have. And suppose we are saying this first one, this is the fourth flag. So by choosing these 4 flags in this order, it will generate a different signal. If suppose I would have chosen this on the first place, this on the second place, this on the third place, and this on the fourth place, this will generate a different signal. So that is why we are saying that we are using the permutation over here, that we are having 6 flags, out of which we have to choose 4 different flags to generate 4 different signals. So answer we have it is 6p4, and the value of 6p4 it is 6 into 5 into 4 into 3, that is equal to 360. Next is 8 athletes are participating in a race. In how many ways can the first 3 prizes be won by them? So number of athletes we have it is 8. Number of prizes we have it is 3. It means we are saying that out of these 8 athletes, I am saying out of 8 athletes, we have to choose 3. So any 3 can obtain the first, second and third place. So we are saying that the number of permutations we have it is 8p3, that is equal to 8 into 7 into 6. But about first 3 prizes, we are not saying 3 prizes, we are saying first 3 prizes. It means for the first place, second place and third place. We are saying this is the first place, another will obtain second place, and another will obtain third place. Now suppose one person has obtained first place, so number of options we have it is 8. If now how many persons are left? We are left with 7 persons. Out of this 7, we have 7 persons to choose for second and 6 to choose for the third place. Now suppose in place of this, it is being given that 3 prizes are to be distributed, that any 3 prizes are to be distributed. It is not first, second and third. We are saying any 3 prices are distributed. Then it is not this case. It is not this case. We will see that how we solve that kind of problems when we will deal with the combination. Because in this case, when we are saying there are 3 prices, it means we are not talking about the first, second and third position. So to get a better insight of this, suppose I am saying in place of 8 athletes, suppose I am saying that we have 3 athletes. They are A1, A2 and A3. We want to distribute the first 2 prizes. We want to distribute first 2 prizes. So we are saying A1 can be first, A2 can be second. We can have A1 can be first. This is first option we can have. Second option we can have is A1 can be first, A3 can be second. Third option we can have it is A2 can be first and A3 can be second. Similarly, we are saying that A2 can be first and A1 may be second. A3 may be first, A1 may be second. And A3 may be first and A2 is second. So the total number of ways we have it is 6. But suppose we are saying, we are not saying first 2 prizes, we are saying that 2 prizes are to be distributed. So we are saying either A1, A2 will get the prize, A1, A3 will get the prize, or A3, A2 will get the prize. Because now we are not saying that A2 is getting the first prize and A1 is getting the first prize. We are just saying that A1 and A2 they are getting the prize. So this is the difference over here, that when we are given that first 3 prizes we are saying, so it is the case of permutation. But if it is being given that only 3 prizes are given, that case we will study in our next lecture when we will deal with combinations. Next is, in how many ways can 3 different rings be worn in 4 fingers? We are saying 3 different rings are to be worn in 4 fingers with at most 1 in each finger. So again we are talking about, we have 4 fingers and we have 3 different rings. So when we are talking about this first ring, I am talking about this first ring, in how many fingers it can be worn? It may be worn in this or this. So number of ways we have it is 4. When we are talking about this second ring, suppose this ring is being worn in this, it is being given that at most 1 is to be worn in each finger. So this second, suppose it is in this, so we are having 3 into 2. This third, for this third we have 2 options. So the answer we obtain it is 24. So the number of ways we have it is 24. Next is 3 men have 4 coats. We have 3 men. Number of coats we have, it is 4. Waistcoats we have, it is 6. And caps we have it is 5. In how many ways they can wear them? Now the number of ways in which 3 men can wear 4 coats, it is 4p3. 3 men can wear 6 waistcoats, it is 6p3. And 3 men can wear 5 caps, it is 5p3. What this thing means is that we have 5 caps, and out of these 5 caps we are choosing any 3 caps. Number of ways of choosing 3 caps out of these 5 caps, and these 3 caps are to be distributed among these 3 men. So these are the number of ways we have. individually. Now any of these three can be out of these permutations. We are saying out of these objects that we have chosen. So by the multiplication principle of combinatorics, we are having it is 4p3, the total number of ways, into 6p3 into 5p3. Now 4p3 means we are talking about 4 into 3 into 2, that is equal to 24. 6p3 we have it is 6 into 5 into 4, the answer we have it is 120, and 5p3 we have it is 5 into 4 into 3, the answer we have it is 60, and we take the product of all these terms, the final answer we obtain it is 172,800. So these are the total number of ways that we have. Next is how many different signals can be given by using any number of flags from 4 flags of different color. So suppose we are saying that one flag is chosen. Second, we are saying 2 flags are chosen, 3 flags are chosen, and 4 flags are chosen. When we are saying that one flag is chosen, number of ways we have it is, the total number of flags we have it is 4. So we have 4p1, that is equal to 4. Next we are saying 2 flags are chosen. When 2 flags are chosen, we have it is 4p2, that is equal to 12. 3 means 4p3 is equal to 24, and 4p4 means 4 factorial, that is equal to 24. Now the total number of ways we have, we are talking about, in this case what we will have, any one of these 4 can happen. We are saying any one of these 4 can happen. So it means we are talking about the addition theorem. We are saying any one of these 4 can happen. So we are talking about over here it is addition theorem. So addition theorem means we have to add all these values. So the total number of ways we have it is 64. That is sum of all these values, it is 64. Now next we have is a code is to consist of 2 distinct letters followed by 2 distinct numbers 1 and 9. So we have 2 distinct letters and then it is to be followed by 2 distinct numbers from 1 to 9. So how many such codes are there, and next is how many of them end with an even integer. So the number of letters we have it is 26. So we are saying we want to make a code with 4 total digits and letters will be there. Now for this first term we are saying, we are saying we will have a letter over here, we will have one letter over here. So basically what we have to do, out of 26 letters we have to choose 2, and for these next two we are talking about the digits, and 2 distinct digits we require. So we will have it is 9 digits are there and it is P2. So the final answer we obtain for this time it is 650 into 72, we get it is 46800. So this is our final answer, 46800. Next is in the second part, it is being how many of them end with an even integer. So we are saying for this case, the first 2 letters that we can choose, we have 650 ways to choose this letter. Then the first digit we are talking about, now about 2 digits. We are saying there are 2 digits now and this digit is to be even. So it means options we have over here, it is 2, 4, 6, 8. Out of these digits, this place is to be filled. So we have 4 options. if one of these digits is filled, the options we are left over here. Suppose 6 is filled over here. We have the options 1, 2, 3, 4, 5, 7, 8 and 9. So total we have 8 options. So the final answer we obtained is product of these 3 terms. So that is equal to the product of these 3 terms, and that is equal to 20800. So these many codes can be formed. Next is find the number of ways in which 5 boys and 3 girls can be arranged in a row so that no 2 girls are together. So we are talking about a setting arrangement. We are saying, suppose we are talking about we have arranged the boys in this way. We have arranged the 5 boys. We are having 1, 2, 3, 4 and 5. We are having, these are the arrangement for the boys we have done. So we are saying now girls can sit at these places. How many places are there? These are 1, 2, 3, 4, 5, 6. So we are saying that out of these 6 places we have to place 3 girls. So the number of ways we have it is 6p3. That is, out of these 6 places we are choosing 3 places. Out of these 6 we are choosing 3 places. And the boys we are talking about, these are the positions of the boys. These are the position of the boys. So we are saying we have total boys, number of boys we have. Number of boys is equal to 5. Number of positions we have, it is 5. So the number of ways in which boys can sit at these 5 positions, it is 5p5. In product of these two, by the fundamental principle of multiplication, we are saying the product of these two will give us the number of ways in which they can be arranged. So the values we have 6p3 when we are talking about, it is 6 into 5 into 4, and 5p5 when we are saying it is 5 factorial, that is 5 into 4 into 3 into 2 into 1. So this value is 120, and this value we are saying it is 120. So multiplication product of both these will be 14400. So we have total these many ways. Next is, there are 2 English, 3 Sanskrit and 4 Hindi books. In how many ways can they be arranged on a shelf so as to keep all the books of the same language together? So we are saying what now we are having 2 English books, we are having 3 Sanskrit books, and we are having 4 Hindi books. Now, how these 2 books can be arranged? These 2 can be arranged like 2p2, that is equal to 2 factorial ways. These 3 books, these can be arranged as 3 factorial ways. These 4 books can be arranged in the 4 factorial ways. After this, we are talking about the arrangement. First, we have kept this English book, then Sanskrit book, then Hindi books. So, how many such arrangements are there? We are saying there are total 3 factorial ways in which we can arrange this. That you can understand it in this way. Suppose I am talking about we have 2 books of English, E1 and E2. I can arrange them in the way E1, E2, or I can arrange in the way E2, E1. Suppose I have 3 books we are talking about of Sanskrit. So it is S1, S2, S3. They may be arranged S1, S3, S2. They may be arranged S2, S1, S3, S2, S3, S1. Then S3, S1, S2, S3, S2 and S1. These books we are saying, these can be arranged in themselves in this way. Suppose we are saying that the first we are arranging this book. So we have E1, E2. Then suppose we are arranging these books. Then we have S1, S2, S3, S1. Next, suppose we are arranging the 4 Hindi books we are talking about. Suppose these are the 4 Hindi books we are arranging. So we are saying we can arrange these books in themselves, and then we are arranging these packets of these books. So the total number of ways we have, it is 2 into 3 factorial is 6, 4 factorial is 24 into the value of 3 factorial is 6. So we are saying it is 1728 ways. So I am again explaining this. We are saying we are taking 2 English books. The number of ways we can arrange this is 2 factorial. We are taking 3 English books. Number of ways we can arrange it is 3 factorial. We are having 4 Hindi books. We can arrange it is 4 factorial. Now these are just like a bundle. We are having this English books as a bundle, this Sanskrit book as a bundle, and Hindi book as a bundle. Now these bundles can be arranged in 3 factorial ways. So this is the next process we are having. So we are saying that we are multiplying this 6 over 8, because this is just like the process one after the other. So the total number of ways we have it is 1728 ways. Next is, in how many ways can 7 examination paper be arranged so that the best and the worst papers are never together? So the total number of ways in which we can arrange these 7 papers, it is 7 factorial, or we are saying it is 7p7. Now suppose we are saying that the best paper and worst paper, they are kept together. We are having papers P1, P2, P3, P4, P5, P6 and P7. Out of this, suppose I am saying this is the best paper and this is the worst paper. Now what we are saying, that we are considering these 2 papers as one bundle. We are talking about these 2 papers, we are considering it as one bundle. So now the arrangement will become P1, P2, this BW will be just like an element, then it is P4, P5 and P7. So the total number of ways now we have it is 1, 2, this is third element, fourth element, fifth element and sixth element. So the number of ways of the arrangement we have it is 6 factorial, and these 2 papers, these can be arranged in the way BW or WB. 2 ways are there, we are saying into 2. So these are the number of ways in which we can arrange the papers when the best and worst paper, they are together. These 2 papers, these are together. So the answers in all these 3 cases, the answer for 7 factorial we have it is 5040, and the answer for the 6 factorial into 2 we have it is 1440. We are talking about these 2 values. The total number of ways in which best and worst paper are together, it is 1440, and the total number of ways of arranging the 7 papers, it is 5040. Now what we want to find is, so that the best and the worst paper are never together. So we are saying the number of arrangements in which best and worst paper are never together, it is difference of these 2. So it is 3600. So these are the number of ways. Next is, in how many ways can 6 balls of different colors, the colors we have it is black, white, blue, red, green and yellow, be arranged in a row in such a way that the black and white balls are never together. So we are having 6 balls. So the total number of ways we have, we are saying we are having 6 balls. So the total number of ways we have, it is 6 factorial, that is equal to 720. We are saying the number of ways when black and white balls are together. How many balls will be left? It is 5 factorial. We are saying black and white ball, they can be arranged in the way 2 ways. But we are saying we are having the black, white, blue, red, green and yellow balls. Total number of ways in which these can be arranged is 6 factorial. Second, we are saying black and white balls are together. We are considering the case when black and white balls are together. We are saying black and white balls are together. We have blue, red, green, yellow. The elements we are left over here, it is the number of elements now we have it is 1, 2, 3, 4 and 5. 5 factorial. Number of ways in which this black and white ball can be arranged is into 2. So the value of this 5 factorial into 2 we obtain it is 240. What we require is they are never together. These two balls, these are never together. So the answer we will have it is 720 minus 240, that is equal to 480. So we are saying there are total 480 ways in which the black and white balls, they are never together. Now next we have is the principal want to arrange 5 students on a platform such that the boy Sajal occupies the second position and the girl Tanvi is always adjacent to Aditi. How many such arrangements are possible? So we are talking about, we have total 5 places. Out of these 5 places, this boy Sajal is always at this place, and Tanvi and Aditi, we are saying Tanvi and Aditi, they are to be adjacent. Adjacent means the number of ways in which these two can be arranged, it is 2 ways. We are saying Tanvi on the right, Aditi on the left, or Aditi on the right and Tanvi on the left. So number of ways to arrange these two girls, it is 2. It is adjacent is given. So one thing is clear, that Tanvi and Aditi, they cannot sit at this first place. So how many students, how many options we are left for this first place? For this first place we have 2 options. The number of options we have, it is 2. For this second place, it is fixed. We have 1 option. Now these 3 places we are talking about. We are left with these 3 places. We are talking about these 3 places. We are saying Tanvi and Aditi, we are considering them as one entity. Tanvi and Aditi, if we consider them as one entity, so we are now reduced to the case that we are having 2 places. Tanvi and Aditi together, say I am writing it as TA. So we are saying we have, out of these 2 places, we have to choose. So the number of ways we have, it is 2 factorial. The ways in which these can be arranged, it is, we are talking about this 2, Tanvi and Aditi, they can be arranged in 2 ways. The second position can be filled in 1 way, and this first position, it can be filled in 2 ways. So the answer we obtain, it is 2 into 2 into 2, that is equal to 8. So the number of ways we have, it is equal to 8. I am again explaining. This boy, we are having it is at the second position. So we are saying there is only 1 way to fill this position. Tanvi and Aditi are to be together, it means they cannot occupy the first position. It means the number of options we have for this first position, it is 2. We are talking about this option. The number of options we have, it is 2. Tanvi and Aditi, they can be arranged in 2 ways. Tanvi on the left, Aditi on the right, Aditi on the right, Tanvi on the left. The number of ways we have, it is 2. Now if we are saying that Tanvi and Aditi, they are one entity, it means that we have 2 seats left. We are reducing it to this case. We are saying that either we can have Tanvi and Aditi over here, or we can have Tanvi and Aditi over here. So the number of ways we have now, it is 2 factorial. We are talking about these 2 cases, Tanvi and Aditi. So the total number of ways we obtain, it is 2 into 2 into 2, that is equal to 8. Next is how many words with or without meaning can be formed by using the letters of the word. We are having the letters D, E, L, H and I, and it is being given that using each letter exactly once. So we are saying what we have to do is, out of these 5 letters, we have to choose 5 letters. So we are talking about 5p5, that is equal to 5 factorial, and that is equal to 120. Next is, in how many 4-letter words with or without meaning can be formed from the word logarithms if repetition of letters is not allowed. So the total number of letters in this word logarithm, we have it is 10 different letters. We are talking about 10 different letters are there. Now we have to make 4-letter words. So when we are talking about 4-letter words, it means we have to choose out of these 10 letters, we have to choose 4 letters. So the answer we obtain, the number of ways of doing this, it is 10p4. So it is equal to 10 into 9 into 8 into 7. I think it is 10 factorial over 10 minus 4 factorial, 10 factorial over 6 factorial. And the answer we obtain, it is 5040. The product of these terms, it is 5040. Next is how many words with or without meaning can be formed from the letters of the word daughter, so that all vowels occur together and all vowels do not occur together. So if we look at these words over here, this word daughter, the total number of letters we have, it is 8. So the total number of words that can be formed, total number of words that can be formed, that is equal to 8p8, that is equal to 8 factorial. Now we are saying the case all vowels occur together. So if we look at this word, the alphabets that we have, it is A, U and E. These are the 3 vowels, and D, G, H, T, R. These are the consonants that we have, 5 consonants that we have. So we are saying that first case we are saying they are all together. So we are considering these 3 words, they are all together, means I am talking about 1, 2, 3, 4, 5, 6 places are there. In these 6 places, I am talking about this whole packet. Say I am saying this is vowel. I am naming this whole packet as vowel. So I am having 1, 2, 3, 4, 5 and 6 objects that I want to arrange now. So the number of arrangements that I can make, it is 6 factorial. And when I am talking about this packet itself, which contain vowels, these 3 vowels, they can be arranged in themselves in 3 factorial ways. These vowels, they can be arranged in themselves in this packet, we are saying they can be arranged in 3 factorial ways. So the total number of ways we have, it is 6 factorial into 3 factorial, and on multiplying these two, the answer we get, it is 720 into 6, that is equal to 4320. Now the total number of ways we have, the total number of ways in which we can the ways in which we can arrange them, or number of words that can be formed, it is 8 factorial. The answer for 8 factorial, it is 40320. The number of ways in which the required number of words with vowels together can be formed, in which vowels are together, it is 4320. So what we are left over here is, that the number of ways in which all vowels are never together, the number of words in which all vowels are never together, it is difference of 40320 and 4320. The answer we obtain, it is 36000, that is 36,000. So these are the number of ways when all vowels, they do not occur together. Next is how many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated. Number 1, when 4 letters are used at a time. We are saying 4 letters are used at a time. So total number of letters we have, it is 6. Now for this first case, we have to make 4-letter words. So we are saying out of these 6 words, we have to choose 4. So the answer we obtain, it is 6 into 5 into 4 into 3. We are saying it is 6 factorial over 2 factorial. It is equal to this, and the answer we get, it is 360. Second is all letters are used at a time. So all letters are used at a time means we are talking about the case when we are choosing all the 6 letters. The answer we have, it is 6 factorial, and the value of 6 factorial we have, it is 720. And last, it is all letters are used but the first letter is a vowel. So the vowels we have over here, we are talking about the case, the vowels we have over here, they are O and A. So at this first place, we have two options. Now for the rest of the 5 places, we are saying 1, 2, 3, 4 and 5 places we are left with. One of them is, suppose O is used over here. Now the terms left over here, it is 5 terms. So the number of ways we can arrange over here, it is 5p5, that is equal to 5 factorial. So the total number of ways we can do this, it is 2 into 5 factorial. And the answer we obtain, we are saying the number of ways, it is 2 into 5 factorial, and 5 factorial is 120. So 2 into 5 factorial, it is 240. So we are saying there are 240 ways when the first letter will be vowel. Next is how many words can be formed from the letters of the word triangle. How many of them will begin with T and end with E? So the first question we have is how many words can be formed from the letters of the word triangle. So there are total 8 letters, all are different over here. So the total number of letters that words can be formed, it is 8p8, that is equal to 8 factorial, that is equal to 40320. Now we are saying that it should begin with T and end with E. How many letters we are left with is 6. For this case, we are saying there is only one option to do this. So how many ways are there? It is 6p6, in which we can arrange the remaining 6 letters. Answer we obtain, it is 6 factorial, that is equal to 720 ways. So the answer for this first part, it is 8 factorial, that is 40,320. And answer for this second part, we are saying for which the words which begin with T and end with E, we have fixed 2 places. So the answer we have, it is 720. Next is how many words can be formed from the letters of the word ordinate so that vowels occupy odd places. So the vowels we have over here, they are O, I, A and E. So there are total 4 vowels and 4 consonants. Now it is being given that the vowels occupy odd places. So we are saying 1, 2, 3, 4, 5, 6, 7, 8. Vowels are at these places. We are saying at this place it is vowel, vowel, vowel and vowel. So basically what we are saying, for these 4 places, we have to choose these 4 vowels. So the number of ways to do this, it is 4p4, that is equal to 4 factorial, that is equal to 24. Now at rest of these places, we will have consonants. And how many consonants we have? It is again 4 consonants we have. Now from 4 consonants, we have to arrange these 4 consonants at these 4 places. So we have 4p4 again, that is equal to 24. So the total number of ways we have, it is 24. That is, first we are arranging the vowels over here. Then next we are arranging the consonants over here. So we are talking about the fundamental principle of multiplication. The answer we obtain, that is 24 into 24 is equal to 576 ways. The total ways we have, it is 576. Next is how many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated. So we are talking about 3-digit numbers. The total numbers we have, it is 1 to 9. So the answer we have, it is 9p3, that is equal to 9 into 8 into 7, that is equal to 504. Next is find the number of 4-digit numbers that can be formed by using the digits 1, 2, 3, 4, 5 if no digit is repeated. So the first part we are saying that out of these 5 numbers we have to choose 4 numbers. The answer we have it is 5 into 4 into 3 into 2, that is equal to 120 ways we are saying. Next we have how many of them are even. So when we are talking about this case, we are saying we have to choose, we have 4-digit numbers. This last place, it can be occupied by 2 or 4. So the number of ways we have, it is 2. We have to choose out of these 2. So basically we are saying it is 2p1, that is equal to 2. Now for these remaining 3 digits, we are saying for these remaining 3 places, how many digits we are left with. Suppose we have filled 2 over here, we have filled 2 over here, we are left with 4. So the number of digits we have, it is 1, 2, 2 is being left. So we are saying 1, 3, 4 and 5. So we are saying the number of ways in which from these 4 letters we can choose 3 letters, it is 4p3, that is equal to 4 into 3 into 2 is equal to 24. What we are doing in this process, we are filling this last place. After that we are filling these places. So by fundamental principle of multiplication, the final answer, the number of even numbers, the required number of even numbers, it is product of these two terms, that is 24 and 2. So the answer we obtain, it is 48. So we are saying the total number of ways we have, or the total number of numbers we have which are even, it is 48. Next is how many 6-digit telephone numbers can be constructed by using, we are talking about 6-digit telephone numbers. The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we are having 10 digits. Now the condition given over here is that each number starts with 35 and no digit appears more than once. So we are saying that the first 2 digits, they are fixed, it is 33 and 5. We are left with 4 more digits, and for these 4 digits, how many, this 3 is being occupied, 5 is being occupied. Now we are left with the number of options we are left with, it is 8. The number of places we have to place them, it is 4. So we have to choose 4 number out of this. So we are saying the number of ways we have, it is 8p4. For this first digit we have 1 option. For this second place we have 1 option. For rest of these 4 places we have 8p4 options, that is equal to 8 into 7 into 6 into 5, that is equal to 1680 ways. We are having 1680 ways.